All right, welcome. This is Unit 4, page 6 of your notes. We are working on the limits. So far you have looked at graphs and determined the limits. Recently we made some graphs from some limits. Now we're just going to actually look at some algebraic information, and this is like the first step in doing some of this. If they give you a problem, so like on page 6, so part 2. Computing a limit. So if they give you just a specific number to plug in, so there's no fractions, there's no zero to worry about, there's no square roots to worry about. If they just give you a number to plug in, go ahead and plug it in. If it's not in any places that will cause a problem, then just work with it straight away. So take the 5, plug it in. So you get 25 minus 20 plus 3, so you get 8. So for this graph, if we were to graph it as x is approaching 5, the y value would be approaching 8. So some of it is very straightforward. Of course, not all of it's going to be that nice, but some of it is. So letter B, same kind of thing. I have a specific value. If you want to pause it and make sure we get the same answer, now's a good time. Otherwise, go ahead. And so there's no fractions or nothing to worry about, which we'll get into later tomorrow. Plug in negative 2 cubed plus 2 times negative 2 minus 4. Negative 2 to the third power is negative 8 minus 4, which is negative 16. Okay. So for this function, as x is approaching negative 2, y is approaching negative 16. Now, the next thing we're going to look at, like, what happens if you don't have an actual number to plug in. Infinity is more of a concept, an idea that numbers go on forever, but sorry. So we're just going to kind of consider and think about it for a second. You're going to follow like what happens when you do stuff to exponents and that sort of stuff. So really, I'm taking a number, although I know infinity is not an actual number, but you're going to plug it in and think about what happens. Okay, a positive infinity, order of operation says exponents first. Positive infinity to a fifth power is going to be even larger. So we'd have 2 times positive infinity. And really, this is a really big number, and then 2 double that again, you're really just kind of determining, was it going towards, is it going towards a positive infinity or a negative infinity? And really you're just looking at exponents. If it's a negative, what is the exponent going to do to the negative? And if you have a number in front, is it going to multiply by a positive, or is it going to multiply by a negative and ultimately make it be a positive or negative answer? So on letter B here, so I'm plugging in negative infinity, or thinking about what does negative infinity do as it's going to the fifth power and multiplying by 2. So a negative to an odd power is still going to be negative. So that's what we're kind of concerned about. Over here on A, when it did to an odd power, it stayed positive. So a positive number times 2 is a positive number. On letter B, the negative infinity to an odd power is still a very large negative number. Times 2 ultimately gives me negative infinity. Alright, so that was, if you look at the difference, if these two, A and B versus C and D. A and B, they only had one term to deal with. Now, I have multiple terms now. I have 2x to the 4th, 3x and minus 2. I have, on letter D, I have negative 2x to the 7th, minus 8x plus 5. Really, the only thing, when I'm plugging in infinity, the only thing that's really being controlled, or the infinity is going to be affected by, is the biggest degree term. So it's going to control the answer. Because really, if you're doing infinity, and you're doing it to an exponent of 4, is subtracting 2 really going to change much? It's going to be very, very tiny compared to the degree of 4. So really all your focus is what's happening with that lead term, because everything smaller than that is not changing it by much. So you really focus on the degree term. So I have 2x to the 4th. That's my focus. So I plug in 2. I have infinity to the 4th. Okay, positive to the 4th power is still positive. So I have 2 times of even bigger infinity, which gives me positive infinity again. Letter D, same kind of thing. I have 3 terms here. No fractions to deal with, I just have 3 terms. So what my thing is like, okay, what controls it? What affects it the most? And the adding 5 is not so much, the minus 8x is a little bit, but really the affecting it is because of the negative 2x to the 7th. So this is what you use to determine the limit, because that is going to affect it the most. Alright, so I think about in terms of my powers and my negative signs. I have negative 2, and negative infinity to the 7th is going to make that stay a negative number, really big negative. Then multiply a negative negative, I ultimately get a negative times a negative cancels out, so it leaves me with positive infinity. Sorry. Alright, last thing here on page 6. Now, I have a piecewise function here. If you are given the problem, so I'm asking you about the limit at 3. So if the number you're asking about the limit matches both of these numbers, you need to plug it in for both of them, because I need to figure out what's happening on the left side of 3, left of 3, and I need to figure out what's going on the right side of 3 to see, do they match? Okay, it's a two-sided limit, especially when it's on the questionable. It's the graph. Is a graph going to 2 different places, so then it does not exist? Is it actually coming to the 1 point? So it does. So I need to figure out what's happening on these 2 pieces to see, are they separated or are they actually attached to each other? So you might come in at the limit here and have it be the same value. Alright, so 3, here's the left side of 3, here's the right side of 3. Now I know that because smaller than 3 would be numbers to the left of 3, and bigger than 3 would be numbers to the right of 3. So that's how I know. If it's a smaller, it's the left side. If it's bigger than that, it's the right side. So to the left of 3, I'm going to take the number like I did for A and B. Oh, sorry, up here A and B. Take the number and plug it into the top. So I do 3 squared minus 5 is 4. Alright, so my left side is coming towards a positive 4. My right side, I plug it in, I get 3 plus 13, I get the square root of 16, I get 4 again. Okay, since these match, the limit is equal to ultimately 4. If it was 4 and a different number, like 4 and 12, then it would be does not exist, DNE. Okay, so ultimately the left and the right match, so I have a graph that's coming together. The double-sided limit, the left and the right side is coming to the same number, so they are going to match. Now, what happens on letter B here when I asked about this number, but it's not where the 2 graphs might join or might split. So I need to figure out, where does this fit into these numbers? So negative 4 is less than 3, so I want to plug this into the top equation, top value, something like that, whatever you want to call it, x squared minus 5. Okay, so this is smaller than or equal to 3, so I'm just going to plug it into the top one because that's where it would fit on the graph. And so I plug in negative 4 squared minus 5, I get 16 minus 5, and I get 11. Okay, so again, and the piecewise function, if you are giving the number here that is actually where it splits between the two pieces. You need to plug it into both and see if the left side, that would be the left side and the right side. See if they come to the same number for that value, or if they go to different numbers so it doesn't exist. And for a number that is not on like the separation of these, the piecewise function, plug it just into where the -4 fits in terms of the xn is less than or equal to, or the x is greater than. So just plug it into the one part where it's fits in for the x value. All right, so for tomorrow, finish up on page 8. You have 4, 5, and 6. Oh my gosh. Right here, number 6, I don't know if yours is like that, but do the limit as x is approaching 2. Okay, so mine didn't copy very well, but do the limit as x is approaching 2. Everything else on mine seems fine. Let me know if you have questions. Bye.